In this video, let's discuss about the most important feature of Oracle 23 AI, which makes it ready for AI, which is a vector. So let's quickly discuss about the theory around the vector, and then I can show you how to download the model, how do you load the model, and how do you generate the embeddings and do semantic search. Yeah. So, vector, what is a vector? So, you might have heard of this term during your high school maths and physics. So, basically, uh, scalar is a quantity that has only magnitude. Like best example is speed or distance. And vector, it has a direction, speed in some direction, so forward or backward, or displacement, velocity or displacement. So, that is vector. So if if you look at the left hand side, so this is two-dimensional vector. So if I say 1 comma 4, 1 on the y-axis, and this is let's say 4 comma 5, so 4 on the x-axis and 5 on the y-axis, it is represented as a point on the two-dimensional space. And if you say the vector is three-dimensional, 1 4 5, then you get a z dimension as well, x, y, and z. So the vectors, usually the AI models that support, it has a lot of dimensions. For example, Cohere one, it has 1000 dimensions. So it is the way the data, it can be text, it can be visual, or it can be audio. It is represented numerically on a multi-dimensional space. That is a vector. And so within the Oracle 23 AI database, like it has the capability. So you can download it within the DB. So that makes it more secure. So you will load your model, or you can use the models from OCI. So it is you use something called ONNX models, which is Open Neural Network Exchange models, or you can call a external embedding model, which is embedding basically. Let's say if you give it a word hello, it will create a vector for it, and it is just a numerical representation of that word hello. So that is a vector. And you can see here some example models I have taken. So for text, you have word to vector, so which is like each word, transforming each word into a vector. So, and the newer ones like transformer based models like GPT, far more advanced. It can embed entire text or even files into embeddings, into vectors. And visual, like audio, not audio, visual, it's images or videos. These are embedded using the deep learning model, such as residual neural networks, ResNet, or audio to speech, or audio to text. So that is a use case, and for that we use embedding models like OpenL3, which will convert the audio into embeddings. So as you can see here in the right hand side, so all of this is different types of data: image, documents, video, and audio. And this uses an embedding model, for example GPT or llama, or you have loads of models in hugging on the Hugging Face. um, and then these are converted into vector embeddings. So once they're converted into vector embeddings, they must be stored somewhere so they can be used. And you can perform semantic search, you can do summarization, all kinds of activities using the model, that's capabilities. Okay, so now this is the theory of it. Hope you got a basic understanding of what a vector is and what is an embedding. Let's look at what we can do to load these models into database and generate embeddings. Yeah, once you have installed, and you can use the Docker. And if you don't know how to do it, you can go to my channel. There is a that I have made another video, so you can use this. So once you have installed, it would appear, it will be accessible. So the next step is, so you log in as this user. You don't have to log in for this actually for the first step. So you will use this link, where this is a link from Oracle, and it has this model link for this model, all mini LM. So this is from Hugging Face, and then you can also access from, you can also access it from here, from Hugging Face transformers, or directly copy this link. I'll give you the link in the description. So it will download. So once it is downloaded, like I've placed my documents in my local, I've downloaded it, unzip it. So it will have this ONNX and then augmented text, just read me about it. So the next step is you need to copy these files or mount this directory into Docker. So you can load this into the database. So for this, I've not mounted the local directory, but I have just executed, I've created a directory and copied the files. Yeah, so these are the commands. So you do create the LLM models directory within the scripts, and then from the local directory, give your local directory path here, and then copy the files in there. So once you copy the files, it will appear like this. So you can see ONNX all mini LM L12 V2 ONNX, and then augmentation readme file is copied. So once these files are copied, then next step is you, this is logged in as sys user assets or sys or system sys DBA basically. So you create this directory, DBA directory. So if you are from Oracle background, so you must be familiar with the database directories. So you create this database directory. Yeah, and database directory is created. Now grant developer mining role, all these yeah, mining model, all these roles to HR user. So you might have, you will need to create a HR user and provide these roles to HR user. Once you have provided, now log in as HR user. Yeah, log in as HR user, and because I have already had already loaded, and just to show you, you can drop the model as well. Let's say if the model, you want to load a new model, yeah, you can drop this. So yeah, drop the model, and then this is the code to load the model. So you just give the directory. Directory is nothing but what you have created here, model directory, right? This is DBA directory, and then you give the file name, and then you give a name to the model. So here I've given the same name as the file name. So let's run this. Yep, it took 5 seconds. It has loaded. So you can check, you can query this table to see all mining models, whether it has loaded or not correctly. So it shows owner is all, and this is the model name, and function is embedding, and all that stuff. And you can see here the model size also. Yeah, because that just says the number of parameters. And here you can see the model attributes. So here you can see the vector info, so 384. So you see here, this is interesting part. So when we say 384 float 32, this is vector dimension. So that means number of dimensions your data will be represented. Say if you pass a word called let's say London to this, So it will represent that word in a 383 dimensional space. And this is the vector format. So each of that will be will be a float 32 numerical value. Okay. So because we have loaded this model now, let's quickly test it. Yeah. So all I'm doing here is I'm using the function, so vector embedding, and I'm saying the model name. So this is a model name using input. So this is a bind variable I'm passing here. So let's see what it does. So if I say hello, 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 yeah. So let's see what it does. Okay, it has created some embedding. As I said, this is just a numerical representation of that word hello. So even if you copy this and put it on a reader, it wouldn't make any sense because it's just numerical representation, right? So its model is creating this embedding. So let's try something similar, but I'll just take one word out of it, or I'd say, yeah, let's just take one letter out of hello. I say hello and click on apply generate for this. So they're almost similar, but it wouldn't make any sense because it doesn't say like you can't make it from this one whether this vector is same as this vector, right? So for that purpose, what um, we have a function we can use in the databases which is called vector distance. So basically, vector distance will say how far is this vector from this vector, and based on the how close it is, based on how close the vector is, it will return the values based on it. Yeah. So let's give it a let's take an example. Let's say I have a table. So I'm creating a table with text data ID and text data. Okay, just a simple table. And then I'm just doing some random data here, like codes, dresses, and then Oracle, Java, and then some country names, continent names, and all that. Okay, let me try to run all of this. Yeah. Then if I select from this, say if I have to select all the dresses from this one, so I'll have to do it's tough because it's there's no pattern or anything. So I'll have to do coat or jacket or shirt, something like that, right? So instead, what I'll do here is, so here you can see vector distance. It is calculating from input to the text data. So this is my data and I'm giving my input. Let's say user wants to search, um, just give me the identify the dresses from this data set. So if I say here dress, yeah, okay, let's see what it does. Okay, so you can see here there is no direct word called dress in my data set. So what it has done, the model has done, it has created a vector embedding for my input, which is the text dress, and then it compared the it has generated embedding for jacket, and it compared whether it is in semantically same or not same, closer, semantically closer. So here you can see it has 0.51 blah blah blah, but this indicates like this takes the closer it is, right? So the less value this is vector distance value, because by default this uses a cosine similarity function, which we will talk about what different kinds of distance functions later. But for this purpose, so you will just consider the least value here. So you can see here it has taken jacket, shirt, coat, and there's nothing else after that. So I've given the name, similar sounding name here, COTE, which means cottage, but it has not taken it. That means model understands, okay, this is different from this, totally different from this, right? Um, and then let me try something else. So I'll just say state. Okay, there's no word called state here. So let me see. So when I do state, it's country, it's similar. Europe, it is similar. Europe, that's a continent. In England, India, continent. For some reason, it has put in Indonesia. I don't know why, because this is where the models, each model behaves differently. So maybe S and S, it is closer to the text. Maybe it considered that it shouldn't be. But let's consider another example. So let's say if I take Oracle. Oracle, I have a text, I have a word, so it is zero. Basically, there's no difference between that. So it is the distance is zero. That means it is exactly same. And then it has taken Java. So it looked at it and said like Oracle is related to Java. And then this is not very closely similar, but in the given data set, because this is it has ignored JSON. Maybe this needs some training. Uh, and Indonesia. So maybe I'm guessing it is linking it with the Java and taking Indonesia as the answer here, but it is 0.66. It is not closer. So let's take another, and I'll just do Jack. There's no Jack here, right? Let's see what it does. So you can see here there is no it has given JSON at the top, right? So when you order it by vector distance, that means it is saying this is another person's name. It looks like a person's name, but rest of them are nowhere near. Yeah, and let's try another example while we're at it. So coat, COAT coat. Let's see what it does. Okay, it's coat. There is a direct match, and then jacket, shirt. Yeah, so it has taken all the dresses first, and you see here the difference 0.28. This is much closer to the coat. So this is how it identifies based on the semantic search. It based on this vector distance. Okay, and then you have you can basically order it by vector distance, descending or ascending. So then we have we'll fetch first n rows, because you don't want suppose you are searching for dresses, you don't want anything that is after a particular um, vector distance, more than a particular vector distance. So you can just say this, so fetch first 6 rows only. Yeah, yeah. So it removes the rest of the rows. And you can also, the beauty of this uh, with this is, say you have your local data and you generate embeddings from external data, or you generate embeddings on your local data as well. So you can combine the searches. You can do all your where clause, group by, apply functions. You can't apply functions to vectors other than the vector distance or any DBMS vector functions. But on your other relational data, so you can apply all these functions, and that is called hybrid search. And then if there is too much of data, and if the queries are taking a lot of time and you are not particular about um, exact fetch, in that scenarios you can do something called approximate. So that means it will quickly fetch the approximate first 6 rows, or first n rows, whatever you enter here, n rows. Yeah, so that's how this is. And it's very important concept, because you will be generating vector embeddings for using in almost all of the AI use cases. So without vectors or generating vector embeddings or understanding vector distance, you can't understand any of the RAG or AI based solutions. Okay, hope this helps. Thank you.